everyone. So it's Tuesday, August 14th, and today's lesson is on inductive reasoning. I appreciate you watching the video while I'm away at training today. So these are the four things that we have for geometry class today. So the first thing you should have done before you started watching the video was to edit yesterday's practice that came at the end of the lesson. For lesson 1.2, so I posted in your Google Classroom the answer key for the 1.2 practice, and be sure that you started by editing that. So if you haven't edited that practice from yesterday's lesson, go ahead and pause the video, go back and edit that practice, and then come back to the video when you're ready to go. So this is actually the second time through the video because the first video was too long and wouldn't upload. So I'm going to do the video in two parts. So we'll do part of the video and then you'll have to go back and watch the second part of the video. So we're going to start today with inductive reasoning, and our lesson today has two pieces. So we're going to do a page in the notebook on inductive reasoning, and then we're going to do the lesson from the book, from the Springboard book on inductive reasoning, lesson 2.1. So we'll start with our notebook, and then after we're finished with the lesson, you'll have plenty of time left, and the substitute will have for you what we call a doodle note, which is just a page for you to practice the circle vocabulary that we worked on yesterday. And the notes are really clear on there. Just follow the to-do list on the circle vocabulary and turn that in by the end of class today, and you'll have plenty of time to get this all done today during class. All right, so we're gonna start with the notebooking page. Now, anytime you need to pause the video to get caught up, go ahead and do that, and that won't be any problem at all. So you know that when we start in the notebook, the first thing we're going to do is write the number for the lesson, which is 2.1, and the title. So today's title is inductive reasoning. So in geometry, we use two different kinds of reasoning. We use inductive reasoning, and then we use deductive reasoning. So today's lesson looks at the first kind of reasoning, inductive reasoning. And then tomorrow's lesson, when I'm back with you, we'll look at deductive reasoning, and we'll also look at how these types of reasoning are alike and different. So after we write the title and the number, then we write the learning targets. So remember, we're going to take those learning targets and turn them into statements, into I can statements. So the first one is I can make conjectures by applying inductive reasoning. And the second one is I can recognize the limits of inductive reasoning. So you want to write down, please, those two learning targets at the top of your page. Now, if you'll notice, I underlined the word conjecture, and that's because that's the vocabulary word in this lesson. So yesterday the lesson was rich with many vocabulary words, and we only have one in this lesson. So we'll look at that one vocabulary word, conjectures, in just a few minutes. So go ahead and get those learning targets done, and when you're ready to go, then we'll move right on. So we're going to start this lesson with a graphic organizer about inductive reasoning. So we'll draw a triangle. So inductive reasoning usually starts with a fact. And we take that fact and we search out some clues to help us get more information about that fact. And then we take the fact that we started with and the clues that we gather, and then we can draw conclusions of what we think based on the fact that we started with and the clues that we gather. Now the thing about inductive reasoning that you'll notice here is that we're not all going to draw the same conclusions. So with inductive reasoning, it's often that many different conclusions can be drawn from the same fact that you started out with. And where it says I can recognize the limits of inductive reasoning, that is the biggest limit of inductive reasoning, is that we often don't draw the same conclusion when we're doing inductive reasoning. And these conclusions that we draw, that's called making conjectures. So those are called conjectures. So if you look in the back of your book in the glossary on page 651, or you can just take my word for it, that's in the back of your book on page 651. In the definition for conjecture says, a conjecture is an unproven statement that seems to be true. So, since it's an unproven statement that seems to be true, that kind of makes sense how we might all think different things. Because we start with a fact, we gather some clues, and we might have different conjectures. We might decide different things that to us seem to be true based on the fact that we started with and the clues that we gather. So let's look at an example of what that might be. So oftentimes inductive reasoning might look like a number pattern. So if we started with a number pattern like 2, 4, 8, and we might be trying to conjecture what might come next. This would be our fact, 2, 4, 8. And then we'd want to find some clues based on these numbers of what we might think might come next. So what I'd like you to do is think about for a minute what you think might come next. And there's one that's probably really obvious to you, but there might be others that if you thought about it for a little while, you might think of something else. So you might even pause the video for just a minute and see if you can think of some different things that might come next after 2, 4, 8. Okay, so it's probably pretty obvious to most everyone that one of the most common patterns here is multiplication by 2. 2 times 2 is 4, and 4 times 2 is 8. So we could continue multiplying by 2. 8 times 2 is 16, and 16 times 2 is 32, and 32 times 2 is 64. And that's the most common pattern that people see when they look at this sequence, 2, 4, 8. And some people would call that powers of 2. 2 to the first is 2, and 2 to the second is 4, and 2 to the third is 8. And that's a very common pattern. But that isn't the only conjecture that you might make if you look at 2, 4, and 8. And I wish I was there to hear what other things you might possibly have come up with when you think about 2, 4, 8. If we think about adding, 2 plus 2 is 4, and 4 plus 4 is 8, and 8 plus 6, if I just add 2 more every time, that might be one possibility. I could add 2 more each time. If if I did that, then 8 plus 6 would be 14. And then the next one would be plus 8. And 14 plus 8 would be 22. And then the next one would be plus 10. So 22 plus 10 would be 32. And this pattern could continue on. And so that might be another pattern. What did we say this one was? Powers of 2? And I have seen over the years that students come up with lots of different possibilities for different patterns of 2 that can exist here. We're going to go ahead and draw one more list here, and we're going to leave one more option open here, because when we explore the lesson in the book today, we're going to come back and write another possibility that can happen here for 2, 4, 8. So we'll leave that at the bottom of the page open as a possibility. So we'll leave that to come back to. All right, and then I think at that point we'll be done with the notebooking page, and we'll call that a wrap for this video, and then we'll come back with part 2. And go ahead and get your Springboard book, and we'll come back and do part 2 of the video.